I will be doing section 12.1, which is one-way analysis of variance. Here I have a table set of the average food consumption by country in kilocalories, which is shown below by continent. The first step is stating the hypothesis. Because there are 5 different categories, the null hypothesis is M1 equals M2 equals mu3 equals mu4 equals mu5. Because this is a one-way analysis of variance, this means that the alternative hypothesis is that at least one of the means differs from the others. The next step will be solving for critical values. The first thing that you need to know before figuring out what your critical values are or what your K and N values are. So K is 5 because there are 5 columns, and N is 31 because there are 31 different data points. To find the critical values, you will need to use your calculator. The first thing you will need to do is turn on your calculator and then press the home button. You will then need to scroll until you get to the stat list editor option on your home screen. You will then go to F5. You will then press 2 for the inverse option. You will then press the 4 button for inverse F. Once you are inside of the inverse F function, you will see 3 different blanks to fill in: area, NDF, and DDF. Within the area, type in 0.95. I forgot to mention earlier, but for this problem set, there is a 0.05 level of significance. The NDF is K minus 1. Because K is 5 in this problem, that number would be 4. Your DDF equals N minus K. This is 26 for this problem. After pressing enter, you will receive your critical value, which for this problem is 2.742. Next step that I will be showing you is how to make a graph for one-way analysis of variance. For this problem, your shaded area will be to the right. The level of significance always equals the area of what is inside of the shaded area. Your critical value will be the lowest value of your shaded area. Solving for the test value is a long and complicated way of solving it on your calculator. The first step is to go to StatList Editor, as I showed you before. Next, within StatList Editor, enter within the list 1, 2, 3, 4, and 5 the data values as shown in the table. The next thing you will do is type in second F1 once your table is complete. This is also known as F6. Next, you will type in alpha with the parentheses, the right side of the parentheses bar, or alpha C. Or you can just scroll down until you see the word ANOVA, which is written in all caps. The next screen that they will show you will have 2 things written. It will have data input method and number of groups. Within each of these, for the data method, click data, and for number of groups, click 5. On the next screen you'll be led to, you must write in your list names. As you can see, it says list 1, 2, 3, 4, and 5, but make sure you write again list 1, list 2, list 3, list 4, and list 5. Once you press enter, your test value will be shown as F. which equals for this problem 4.194. Next, you'll have to summarize your decision. So basically, because the value is 4.194, that means you would reject it because it is greater than 2.742, which means that it is in the critical area. My statement for this problem will be that there is enough evidence to claim at least one continent has a mean weight gain different than the other countries. So the last part of this section is filling out this chart. I've already filled out the chart because it would take way too long for me to write all these numbers out. So basically, the part of our calculator where we just got our test value, if you stay on that section, this is how we can find all the values for this chart. So the first number that I'm going to talk about is the easiest, which is F, which is the first number on the list in our calculator, which is also our test value, which was 4.194. Next, I'm going to go to the between section, which on our calculator is written as factor, so that might be a little bit confusing. First, I'm going to talk about the between sum of squares. On our calculator, it is demonstrated by two capital S's, and that number is 5,550,538. The next is degrees of freedom, which on our calculator is demonstrated as lowercase d and f. And for the between or factor, I got 4. The next section is the mean of square, which on our calculator is demonstrated as capital M and capital S, and I got 1,387,634. The next section that I will talk about is the within section, which on our calculator is titled air, so it can get a little complicated with different sections for the title, but once you figure it out, it's really easy. So our sum of squares, which yet again is characterized by two capital S's, is 8,603,009. The degrees of freedom, which is characterized by lowercase d and f, is 26, and the mean of squares is 330,885. So our totals is basically just as it's described, is adding the sum of square, the between and within sum of squares, as well as the degrees of freedom between and within. So I hope this video helped to demonstrate a little bit more about section 12.1 or one-way analysis of variance, or ANOVA. Thank you.